Welcome to Deep Learning, like that. Welcome to the Kaggle's introduction to deep learning. You're about to learn all you need to get started building your own deep neural network. Using Keras and TensorFlow, you will learn how to create a fully connected neural network architecture, apply neural nets to two classical ML problems, regression and classification, train neural nets with stochastic gradient descent, improve performance with dropout, batch normalization, and other techniques. The tutorials will introduce you to these topics with fully worked examples, and then in the exercises, you'll explore these topics in more depth and apply them to real-world data sets. Let's get started like that. What is deep learning? Some of the most impressive advances in artificial intelligence in recent years have been in the field of deep learning, natural language translation, image recognition, and game playing are all tasks where deep learning models have neared or even exceeded human-level performance. So what is deep learning? Deep learning is an approach to machine learning characterized by deep stacks of computation. The depth of computation is what has enabled deep learning models to disentangle the kinds of complex and hierarchical problems found in the most challenging real-world datasets. Through their power and scalability, neural networks have become the defining model of deep learning. Neural networks are composed of neurons, where each neuron individually performs only a simple computation. The power of a neural network comes instead from the complexity of the connections these neurons can form. It's actually quite a lot of fun. The linear unit. So let's begin with the fundamental component of a neural network, the individual neuron. As a diagram, a neuron or unit with one input looks like X and 1. The linear unit. Okay, so this is where I'm starting to, I have to figure out what this means. X and 1. So X is, I guess, is a variable number. 1 is a constant. What does W and B means? I think W is the weight and B is what? It's a constant, I guess, that you add. B equal to 1, I guess. The input is X. The connection to the neuron has a weight which is W. Wherever a value flows through a connection, you multiply the value by the connection's weight. For the input X, what reaches the neuron is W times X, which is the weight. A neural network learns by modifying its weights. Actually, this is a good example. So a neural network will vary, for example, the weight from 0. Weight equal to 0 means it will ignore X completely. And then on the other extreme, it will, W equal to 1, it will be taking the whole value of X. But then it will actually vary between 0 and 1. That's the weight. So the weight varies between 0 and 1, if I understand well, or even more. Actually, it can be 2 times X, 3 times X, I don't know, where does it stop? The B is a special kind of weight we call the bias. The bias doesn't have any input data associated with it. Instead, we put a 1 in the diagram so that the value that reaches the neuron is just B. Since 1 times B equal to B, the bias enables the neuron to modify the output independently of its inputs. The Y is the value the neuron ultimately outputs. To get the output, the neuron sums up all the values it receives through its connections. The neuron's activation is Y equal to W times X plus B, or as a formula, Y equal W times X plus B. Okay, this is I think it's familiar to me. I've seen it somewhere. There's a formula Y equal to WX plus B looks familiar. Okay, before I even see what it says there, it looks like the equation for velocity, right? Slope-intercept equation. Like when I was studying physics, I remember seeing something very similar to this. But this was ages ago. Okay, let's see. Too abstract for me. I just want pictures right now. It's like, it's a mathematical function that basically goes, I remember now. So if you don't have the B, actually, you have like a straight line that goes through the origin, which is 0, right? Then plus b, you basically move the line up or down. So that's what it is. I'm pretty sure this is also the equation that you get in physics for calculating a position. Okay. The linear unit as a model. Though individual neurons will usually only function as part of a larger network, it is often useful to start with a single neuron model as a baseline. Single neuron models are linear models. Okay, so we start easy. Let's think about how this might work on a dataset like AT cereals. What's that? There's a dataset. Nice. Nutrition data on AT cereal products. Sounds good. Might be fun. Training a model with sugars, grams of sugars per serving as input, and calories per serving as output. We might find the bias is B equal to 90 and the weight is W equal to 2.5. We could estimate the calorie content of a cereal with 5 grams of sugar per serving like this. So input is grams of sugar per serving and calories is the output. So we're trying to find the relationship between calories and the amount of sugar, right? And it tells me that we might find the biases is equal to 90 and the weight is equal to 2.5. We could estimate the calorie content of a cereal with 5 grams of sugar per serving like this. So this is showing me the diagram. So sugar is 2.5 grams and then B equal to 90. That's the calories. So input sugar is equal to 5. Oh, I see. So 5 times 2.5 plus 90, right? And that gives you 102.5. Okay, multiple inputs. The AT cereals dataset has many more features than just sugars. What if we wanted to expand our model to include things like fiber or protein content? That's easy enough. We can just add more input connections to the neuron, one for each additional feature. To find the output, we would multiply each input to its connection weight and then add them all together. So x0, then you have weight 0, then x1, weight 1, x2, weight 2, x, and this is our bias. In this case, it's B. The formula for the neuron would be y equal to w0x0 plus w1x1 plus w2x2 plus b. A linear unit with 2 inputs will fit a plane, and a unit with more inputs than that will fit a hyperplane. Oh, I see. What is a hyperplane? I think it's probably you have x and y axis, and then I don't know what a hyperplane is. Okay, so a bit of knowledge I didn't know. Oh. From what I understand is, okay, I don't understand this yet, honestly. It says that a hyperplane is a plane that has one less dimension than, I say, at 3 dimensions, and your hyperplane is something that only fits into 2 dimensions out of the 3. But you know, it's the first time I hear it. I'm going to take it easy. I don't want to learn too much at once. Okay, hyperplane. Linear units in Keras. Okay. The easiest way to create a model in Keras is through keras.sequential, which creates a neural network as a stack of layers. We can create models like those above using a dense layer, which we'll learn more about in the next lesson. We could define a linear model accepting 3 input features: sugars, fiber, and protein, and producing single output calories like so. So it's importing the Keras from TensorFlow, importing layers from TensorFlow.keras, and then it's creating a network with 1 linear input unit. So layers.dense unit equal to 1, input shape equal to 3. I'm going to pretend I understand what I'm just looking at. No, I'm just joking. So 1 linear unit. So how many units we want? Our output is only 1, calories. So we use units equal to 1. With the second argument, input underscore shape, we tell Keras the dimensions of the inputs. So in this case, the number of inputs that we have is 3. So we have sugars, fiber, and protein. and the model is now ready to be fed to the training data. Why is input shape a Python list? Why is it not a tuple or maybe a NumPy array or whatever? The data we'll use in this course will be tabular data like in Pandas data frame. We'll use one input for each feature in the dataset, and the features are arranged by column, so we always have input underscore shape equal to number of columns. The reason Keras uses a list here is to permit use of more complex datasets. Image data, for instance, might need 3 dimensions, so it's like variable in terms of number of arguments you can give. Okay, so I've done the theory, and now I'm going to do the exercise. In this tutorial, we learn about the building blocks of neural networks, linear units. We saw that a model of just one linear unit will fit a linear function to a dataset, equivalent to linear regression. In this exercise, you'll build a linear model and get some practice working with models in Keras. Before you get started, run the code cell below to set everything up. So this is just Python notebook, and it runs on its own server. I think Google owns it, but it doesn't really matter for us. I'm just running it, so it's set up everything. I'm going to be using Pandas. The red wine quality dataset consists of physiochemical measurements from about 1600 Portuguese red wines. I'm Portuguese, so I'm proud of that. We have 1600 red wines. We are just like 10 million people, not even that, and we have this many wines. Also included is a quality rating for each wine from blind taste tests. First, run the next cell to display the first rows of this dataset. So we're going to use Pandas for this. So I can see the code is importing Pandas. It's also importing a CSV file, which already should be there. And we're going to have a look at the starting part of the dataset. So this is a good thing to do. So we can find out how many rows and columns by calling this. Why is it not running the first time? So we have 1,599 rows. Hang on, it's supposed to be 1,600, right? However, this is actually not giving you the total number, it's just giving you the highest index. So it starts with 0, it ends in 1599. So the same thing here, it starts with 0 and ends in 12. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, hang on. What's going on? Oh, it's missing the first. No? I'm not sure. Okay. And I can't really just leave this unresolved. So this is an example with 2 columns. 2, okay, 1 and 2. Okay. Right, I don't know. I think it's a number, so it's total number. So I think maybe they only have 1,599 ones. That's kind of odd. Have they made a mistake, or is just something I'm missing? Input shape. How well can we predict a wine's perceived quality from the physiochemical measurements? The target is quality, and the remaining columns are the features. How would you set the input shape parameter for a Keras model on this task? So it would be, instead of 12 columns, we would use 11 columns, right? And then the number of rows would be the same. I'm guessing here. Let's try and... I'm probably going to get it wrong, but you know. Ah, okay. So I have no idea what this is. Why do I have to put this? Now I remember that input shape should be a list, but why underscores, I don't know. Input shape. Let me review the actual theory, because we talked about input shape here and it didn't register to me. So it has a number here because it's the number of dimensions. So it should be 11, right? I think that was close. Okay, input shape and input 11. Yes, okay, that wasn't too difficult. It's good to always have exercises so you basically can test what you actually know or what you understood.